Alright guys, we are starting 7.4, which is on mass, percent composition, and empirical formulas. So it uses the stuff from 7.3 and 7.2 and 7.1 that's a little bit different. So the learning goal is, given the formula of a compound, calculate the mass percent of composition. And then once you know from the mass percent composition, determine the empirical formula of a compound. Alright, let's get started. Okay, so mass percent composition. So given the mass of an element in a compound, we can calculate the mass percent composition of that element. All that means is, by mass, what percent of that compound is each thing. So H2O, we know that that's 2 hydrogens to 1 oxygen. But is it mass-wise the same? Is it twice? Hydrogen takes up twice the mass and oxygen just takes up 1 part of the mass? It's actually not. Oxygen is a lot heavier of an atom. And so mass percent composition of that is way different. So the way we calculate it is the mass of one element divided by the total mass in the compound and multiply it times 100%. All right, the easiest way to do this is just using the molar mass. So we can calculate the mass percent composition of a compound by taking the mass of an element, dividing it by the molar mass, and multiplying times 100%. All right. So here's an example. The odor of pears is due to the organic compound propyl acetate, C5H10O2. What is its mass percent composition? So what we're going to do is we're going to calculate how much of this is carbon, how much of this is hydrogen, how much of this is oxygen, mass-wise. Not atoms, but talking about mass percent. So what percent of its mass is kept up by the carbon, the hydrogen, and the oxygen? So let me get my handy-dandy whiteboard. Hold on. Okay. So I've got C5H10O2. So the first thing I want to do is, what is the total mass of this thing? So we'll do 5 times the mass of carbon, which is 12.01 grams, plus 10 times the mass of hydrogen, which is 1.01 grams, plus 2 times the mass of oxygen, which is 16.00 grams. So I'm going to get my calculator ready. Oops, that's not my calculator. Calculator, where are you? You're right there. Okay. Sorry, computer is being silly. So, go away, Mark, website. Yes. All right. So 5 times 12.01 plus, we want to do 10 times 1.01 plus 2 times 16. You get 102.15. So the molar mass of this compound is 102.15 grams. So that's, if I had a mole of this, it would be a mass of that. So now what we need to do is, how much would the carbon weigh? How much would the hydrogen weigh? How much would the oxygen weigh? Well, I'm going to erase this. So I've erased my work, and just left 102.15 grams, because that's the total mass. Now remember that when we talked about these, let me close this, sorry, about these compounds, we knew that if we had 1 mole of propyl acetate, that would have 5 moles of carbon in it, 10 moles of hydrogen in it, 2 moles of oxygen in it. So let's take that knowledge, so knowing that we have 5 moles of carbon, and let's convert that into what would be the mass percent. And so I know in 1 mole of this whole thing, I have the mass of carbon, the molar mass of carbon, which is 12.01 grams. So all I'm doing is taking those 5 moles of carbon that I have and converting it into grams. So 5 times 12.01 gives me a mass of 60.05 grams. So that's the carbon mass of this. Now let's do that again for the hydrogen and the oxygen. So hydrogen is 10 moles of hydrogen. And we're to find that one's molar mass. Well, we know that 1 mole of hydrogen has a mass of 1.01 grams. What is 10 times 1.01, 10.1 grams. So that's the mass of the carbon in here, or the hydrogen. And then finally we're going to move on to what is the oxygen. So I have 2 moles of oxygen. And the molar mass of oxygen is 16.00 grams. So all I'm doing is converting how many moles of each of these I have into their molar mass. We know 2 times 16 is 32 grams. Okay, so in 1 mole of propyl acetate, I have 60.05 grams of carbon, 10.1 grams of hydrogen, and 32 grams of oxygen. Okay, now to find the percent composition, remember we go back to this equation. You want to take the mass of each element and divide it by the molar mass of the compound. So hold on. All right, so this is my, if I go down, my carbon, my hydrogen, my oxygen. And so I'm going to have to divide these by the total mass of that thing. So for carbon, it would be 60.05 grams divided by 102.15 grams. I'm trying to find the mass composition of just the carbon. How much of the percent of this is carbon? So I take 60.05 divided by 102.15, and I get 0.587, and we multiply that times 100%. So I'm going to go with, and I've got 4 sig figs, so 58.79% of propyl acetate is carbon. Okay, now let's do it for hydrogen. I've got 10.1 grams, so 10.1 grams divided by the total 102.15 grams is, let's see, 10.1 divided by 102.15 gives me, let's see, 9.89% is hydrogen. And then lastly, I've got those 32 grams. So 32 grams divided by 102.15 grams. So doing the last one. And I get 31.33% of it is oxygen. All right, all of those should add up to 100% because we're just figuring out what percent it is. Cool beans, cool beans, cool pears, pears. All right, okay, so they all add up to 100%. We get 58.8, 9.87, 31.33, so we got almost the exact same numbers as the PowerPoint, which is good, and they all add up to 100% because total mass of it is 100% of its mass. All right, so now let's talk about empirical formulas. So empirical formulas, this is something completely different we haven't learned about yet, but all it is the simplest whole number ratio of the atoms in a compound. For something like NaCl, for salt, that's straightforward. 1 Na for 1 Cl, that is the simplest whole number ratio. But some things, like our example we have right here, okay, so this compound right here, these molecular compounds are much more specific to how many. So this is specifically 5 carbons, 10 hydrogens, and 5 oxygens. But that's not the lowest ratio. Okay, we could divide those all by 5 and get 1 carbon, 2 hydrogens, 1 oxygen. We don't usually write the ones, so the empirical formula for that would be CH2O. Here's a couple examples of those. So benzene. Benzene is C6H6. Specifically, they call them hydrocarbons because it's hydrogen and carbon, and specifically 6 of each. However, the simplest formula would just be CH. Ammonia, NH3, that is the simplest. So the empirical formula is the same as the molecular formula. Ribose, okay, think of like ribosomes, C5H10O5, that's that one we just looked at. Glucose, C6H12O6. Again, goes down to its simplest form. So you're basically dividing it to find the most simple form. This is molecular formula, how many actual atoms make up that molecule. The empirical form is just a simpler version of that. And so you can see it's hard to tell acetylene, and benzene both have the same empirical formula, but they are different molecular structures. Okay, so learning check. A, what is the empirical formula for C4H8? So you would divide them both by 4, and you would get number 2. For B, what is the empirical formula for C8H14? What do they have in common? So you can't divide by 8 because 14 doesn't divide by 8. You can divide by 2, right? And that would get you 4 and 7. So number 1 is the right answer. And which of the possible molecular formulas for CH2OO? So this one's already in empirical form. What would be its molecular formula? Well, let's see. If we multiply these all by 2, we wouldn't get this. If we multiply them by 4, we wouldn't get this either. So this one's not a good answer. Let's see. If we multiply by 2, we get C2H4O2. So that one's 1. And then let's see. If we multiply it by 3, we would get this one. So C3H6O3. So numbers 2 and 3 are both right answers. There's our answers. So make sure you understand how we do those. So why do we care about empirical formulas right now? Well, we can calculate them based on the mass percent. So here's a learning check. A compound contains 73.1 grams of nickel and 20 grams of bromine. Let's calculate its simplest formula. To the handy dandy whiteboard. Back with my handy dandy whiteboard. Okay, so we have the grams. If we're going to try and figure out the ratios, we need to go back to moles. Because remember, in the last problem, we had the ratio. We could use moles to get to grams. Now we have the grams. Let's go to moles. So we have 7.31 grams of bromine. Now we need to convert that to moles. So I'm going to put grams here, moles up here. We know 1 mole. If I'm going to grams, remember I'm going from gram island to mole island, I need to ride the molar mass boat. So I need to know the molar mass of nickel. So if I look at the periodic table, nickel has a mass of 58.6934. We'll just do 58.69 grams. Okay, I'm calculating how many moles this would be. So pick up my calculator. 7.31 divided by 58.69. Oops. And I get 0.12 moles. I guess I can have 3 sig figs, so 0.125 moles, okay, of nickel make up this compound. Let's do the same for bromine. So bromine, I've got 20.0 grams. Trying to figure out how many moles of that I have. So I need to use the molar mass. So the molar mass of bromine is, I look at the periodic table, 79.90. Okay, so I'm going to divide 20 divided by 79.9, and I get 0.250 moles. So that means if I have this much of this compound, it's going to be 0.125 moles of nickel and 0.250 moles of bromine. So how does that help me write the empirical formula? Well, remember, the empirical formula tells me the simplest relationship between these two. So what you want to do is divide them by the lowest number of moles. So the lower one is this one, is the nickel. So let's take them both. So nickel would be 0.125 divided by 0.125. That's just going to get me 1, right? So I'm going to have 1 nickel. And then bromine, I'm going to do the same, 0.250 divided by that smaller one, 0.125. Some of you are recognizing that would give me 2. So that tells me the relationship that I have 1 nickel for every 2 bromine. So I could write the empirical formula as NiBr2. Okay, just to recap, what we did was we found how many moles that would be, then divided it by the lowest, and that told us what the relationship would be there. Okay, these slides walk you through that. Let's try another one. Aspirin is 60% carbon, 4.5% hydrogen, and 35.5% oxygen. Calculate its empirical formula. So now they gave us percentages instead of masses. So the easiest thing to do when they have percentages is just make them into the masses, okay? Assume you have 100 grams. If it was 60% carbon, you'd have 60 grams of carbon. So then you need to convert this to moles, Then you need to divide by the lowest number of moles, and then